Students, good afternoon. Now we will continue our class with chemical properties of alcohols. In that mainly reactions involving OH bond cleavage we will discuss. Okay. So as I was given previously, the order of reactivity towards OH bond cleavage. Which alcohol can react faster towards OH bond cleavage? That means who can lose proton easily? OH bond broken means what is the meaning? H plus donation. So who can lose H plus easily means primary alcohols, then secondary alcohols, then tertiary alcohols. So I was given previously and very clearly as minus I groups increases, then OH bond cleavage increases, certainly acidic character increases. Those minus I groups are called electron withdrawing groups. Getting what I'm saying? So if plus I group is there, if plus I group is there or increases, number of plus I groups increases, then OH bond cleavage decreases. Certainly acidic character decreases. This is very important point for us. Okay. So next thing is, see this CH3O H. Okay, and even see alcohol, any water, if you compare H and H. See, water, the Kw value, it's a 10 power minus 14. Do you remember this? 1 into 10 power minus 14. Okay, but here this K value is 10 power minus 16 to 10 power minus 18 actually. That means this has more Kw means. That means water is more acidic. See, than alcohol. Even you take some ethyl alcohol or whatever, CH2 and CH3 and CH2 whatever, ethanol if you take, or simply you take C2H5. What happens here? This C2H5 is alkyl group is what group? Plus I group. Certainly this is donating. So hydrogen come out as H plus means what must happen? This bond must come towards oxygen. When this bond can come towards oxygen easily, if the group what you have here is withdrawing, then only this bond can come towards oxygen, then only H plus can come out easily. But here what happened? C2H5 is electron donating group. Plus I group increases, acidic nature decreases. So H plus donation is not easy. But whereas here there is no alkyl group, both are hydrogen. Still of course water also very much weak acid actually. Water we call as neutral. That's why Kw is 10 power minus 14. Than water this is more neutral. But alcohol is less acidic. So less acidic means we can drink, sir, don't say like that. Some extra, some different things are there, okay, due to consumption of alcohol. So it's not good. Okay, so water has more acidic nature, but still it is more better for us. Okay, so less acidic, it is good for health, don't think. Okay, some effects will be definitely there due to alcohol, side effects. Okay, so this is a highly dangerous, I am saying. Okay, so alcohol is less acidic but highly dangerous than water. So Kw value also I was saying. So what I am telling here, OH bond is there, here some X group is there. This X group what you have, this X group must be electron withdrawing, then only this bond can move towards oxygen. This is final, sir. Okay, certainly on oxygen electron density can increase because this X is electron withdrawing. This something is trying to take, so then this oxygen try to take these bonded electrons. Certainly H plus can come out easily. So this is very clear point I was given, as electron withdrawing group is there, then OH bond cleavage is more. So I was given one important point, that is alcohols are less acidic than what? Water. Okay. So towards OH bond cleavage, who is more reactive also I was given, primary alcohols are more reactive. So if you see next, one more thing, acidic character is more, means this Ka value, acid dissociation constant is certainly more than this pKa value is less. Okay, two acids, if you take acid, something like two acids like ethanol I was consider, and CH3 CH2OH, and I was consider some Cl CH2 and CH2OH. Okay, so Ka value I was given, it is some 1 into 10 power minus 6 I was given, and here Ka value is 1 into 10 power minus, okay, minus 5 something I was given, chlorine. So Ka value is lesser, Ka value is less, then pK value is more, like that we will say. See, suppose now pKa means, what is the formula? pKa is minus log Ka. Okay, now, and here pKa means minus log Ka. Okay, so what is pKa here for this, for the first one? And it is 1 into 10 power minus 6 minus log. Okay, so Ka value is less, pKa will be more. See this? So now it is 6, and here the pKa value minus log into 10 power minus 1. So Ka value is more. Now pKa value is 5 here. Okay, this one here and this one here. Why I given this understood? To understand. So by giving Ka values and pKa values, they will ask you who is more acidic, like that. Otherwise, which of the following alcohol has more pKa value means less acidic. Okay, acidic character is more, pKa value is less. You know the pH values already. pH 1 to 7 means before 7, less than 7 are acids, 7 is neutral, greater than 7 are basic, like that you know na. Less the pH value, more will be acidic nature, like that you know already. Ionic equilibrium we discussed. So here why I given this example, to understand which has more pKa value or which has less Ka value, like that they'll ask you. So very important for us. Got it? So they'll give sir like this: Cl, CH2, CH2OH, Cl2, CH, CH2OH, Cl3, CH2OH. Who is more acidic? Acidic is my question. Who is more acidic? Certainly this is more acidic. That means who has less pKa? This has pKa value less. Why? Acidic nature is more, pKa value is less. pKa less, that means Ka value is more. Don't get confused. So here why I am talking about Ka and pKa, understanding? Like pH sir, pKa means excuse me. So here K, pKa, Ka, pKb, all you have in ionic equilibrium. I was very clear, I was given very clearly, you can check also once. Okay, so acidic character is more for this because number of minus. Here how many chlorines you have? 3 chlorines you have. So here 3 minus I groups you have. Here 2 minus I groups you have. Here 1 minus I group you have. So more acidic is who? This one. Getting? So what I said already, if minus I groups increases, then acidic character increases. So one more most important thing, if distance increases, distance means what? If the minus I groups directly attach to the carbon for which OH group attached, then acidic character is more. Understood? Not understood? I'll give you example. So this is one example, sir. The second example. Now CCCCOH, and here you have chlorine, and CCCOH, and here you have chlorine, and CCCOH, and here you have chlorine. Now see, here you have withdrawing group, here is a chlorine withdrawing group, here chlorine is withdrawing group, but distance matters. See, for the carbon for which OH attached, for the same carbon we have chlorine. Certainly acidic nature is more here. Understanding? So this has more acidic nature than this. So this has more acidic nature than this because distance increasing. Distance increasing. So certainly if distance increases, distance of who? That minus I group. Distance if more, then acidic nature is less. So that point also very, very important. So minus I group, if directly attached to whom? Substrate carbon. Do you remember the substrate carbon means for which the functional group attached as to substrate carbon, then what happens? Acidic character increases. This point is very important. So what I written? Minus I group if directly attached to substrate carbon, then acidic character increases. But if distance increases, then what happens? If distance increases, then acidic character decreases. So this is about acidic character. So do you remember the minus I groups? If you forgot, please revise. Just before starting organic chemistry, I was given who are the minus I groups and who are plus I groups here. So please remember about the pKa value and Ka values also. Okay, and as I was given, as plus I groups increases, then acidic character decreases. Acidic character decreases means what is the meaning? Ka value is less and pKa value will be more. Ulta. Acidic character is less means pKa value is more. Acidic character is more means pKa value is less. Don't get confused. So who is more acidic among these? Suppose CH3OH I was given, and CH3CH2OH I was given, and CH3CH, and here you have OH, and CH2CH3 I was given. Sorry. Yeah. CH3 and CH3C and CH3 and CH3 and OH I have. So among these, which has more acidic? Suppose if you taken 3 carbons, it's not a problem. 2 carbons if you take like this, 2 sides, not a problem. Now you see, this is the carbon, methanol you have. This carbon has 3 hydrogens. So this carbon you compare everywhere. See, this carbon has 3 hydrogens. This carbon has 1 methyl group and 2 hydrogens. And this carbon has 2 methyl groups and 1 hydrogen. This carbon has 3 methyl groups. So number of plus I groups is more here. Certainly acidic character is less here because this alkyl group is plus I group. Do you remember? Alkyl groups are plus I groups. All alkyl groups are plus I groups I was given. Do you remember all these things? So very, very important. So reactions involving OH bond cleavage, I am talking seriously, I am talking about OH bond cleavage only. So who can lose H plus easily? Means this methanol can easily lose, because methanol means like this, 3 hydrogens. Of course methanol is less acidic even than water because total methyl group is donor. Understanding? So here all 3 hydrogens, but here 2 hydrogens and 1 methyl. So as here 1 hydrogen and 2 methyl groups. So as number of plus I groups increases, So acidic character increases. So finally I'll tell you this ROH bond. This OH bond has polarity, and this polarity due to that, and H plus can be renamed. Sorry, H plus can be replaced. H plus can be removed. Okay, so that we can consider alcohols as weak acids finally. Alcohols are weak acids or strong acids? Alcohols are weak acids. Why alcohols are weak acids? Because of ability to lose H plus. So these alcohols can react with the metals. So reaction with metal is possible because who are metals? Metals are basic. Metals has a tendency to lose H plus. Oh my god. Metals has a tendency to accept or remove H plus. Okay. So these metals can replace hydrogen. Sorry. Metals can replace hydrogen. Suppose if I am taking ROH. Now I am treating with sodium here, suppose. Metal. Sodium, potassium. Mainly alkali metals are highly reactive, They can easily replace. Or alkaline earth metals also. So now what you have here? RONA. So what happening? Metals replacing hydrogen from acids. Do you know that? So that only happening here. RO minus and Na plus half H2. If you want to take 2 moles, you can take, no problem. Getting what I am saying? So with metal, what happens? Metal replacing hydrogen from acids. So this ROH is acting as acid. The sodium acting as base. Not only metal hydrides can react. Like ROH when react with NaH, or sir, not only sodium, sir, you can take alkali metal. Write down alkali metals can replace. Like potassium also. Not only sodium, instead of sodium you can use some potassium also. Simply M you take MH. Metal is alkali metal or alkaline earth metal mostly. But alkali metals are highly basic, you know that. Alkali metals can easily replace hydrogen. Now what happens here? Very simple. RONA, same story. RONA plus, so RONA plus H2. Because this is H plus and this is H minus, H2. H plus, H minus, H2. RO minus and Na plus. RONA, RO minus and Na plus. This is another. Got it, sir, clearly? So not only this, with base sodium hydroxide, yes, reaction takes place. This is weak acid, sodium hydroxide is strong base. So ROH plus NaOH. So that you will have RO and Na. Okay, same story. What is that? RONA, RO minus Na plus H2O, OH minus and H plus. OH minus and H plus. So I will repeat, for OH bond cleavage, which alcohols are more reactive? Primary alcohols. And moreover, even in primary, if electron withdrawing groups are there, then reactivity increases. Suppose they'll ask you like this: with sodium, which of the following is more reactive? Which of the following is more reactive? Like that they'll ask you. Like this: CH3, CH2OH. Okay. Next, CH3, CH, ClOH, CH3, C, Cl, ClOH. Who react more? This is first option, this is second option, and this is third option. Fourth option not there, none of these, I don't want. Okay, among these, who is more reactive means this is more reactive to react with sodium. With sodium, who react fast? This one, because this substrate carbon has minus I groups. As minus I groups increases, I told you this bond can come towards this, so this bond can come towards here, So H plus can easily go. Understanding? So fourth option I was not written, but I want only these three. Okay, so among these, who is more reactive? Means this is more reactive. Difference you understood, sir? So as minus I groups increases, reaction with metal hydride and all those increases because acidic nature increases. Written, sir, all this. And last and final, I'll give you one more for today's class. That is reaction with Grignard reagent. Reaction with what? Grignard reagent. See, reaction with Grignard reagent. These all are involving what? Reactions involving OH bond cleavage. Previously with metal what happened? Hydrogen replaced by sodium. So OH bond only cleaved or not? With Grignard reagent also same story happens. Means same thing happens. Do you know what is that? Let's see. Now Grignard reagent means what? RMgX. So RMgX when react with alcohol, some CH3, CH2, CH3, CH2OH. This is Grignard reagent. Whatever the alcohol is unnecessary for you. Understanding what I am saying? So in Grignard reagent, what is the R group? That R group and here this proton, OH bond cleavage or not, tell me. So OH bond cleavage. So what is the product here? RH. Alkane is the product. So final conclusion is what, sir, means Grignard reagent with alcohol, alkane, with what number of carbons? With the number of carbons what present in Grignard reagent. Here what carbons present is unnecessary for you. Actually this is alcohol. This alcohol and this is Grignard reagent actually. Grignard reagent means what? RMgX. RMgX with this alcohol CH3, CH2OH, you are getting RH. And you are having this MgO, C2H5, this X. OC2H5, why are written understood? OC2H5. Getting what I am saying? So, Grignard reagent with alcohol, you are getting alkane. Whatever here, suppose here C6H5 you have, C6H5 MgBr, okay, with some alcohol like ROH. Whatever the alkyl group here, some people are very smart. What is alkane? Sir said RH. RH. No. Alkyl group what you have in Grignard reagent, that forms alkane. What is the alkyl group here? C6H5 and here H. Understanding why I am saying like that? You know, in Grignard reagent this is R minus Mg plus. So it is O minus and H plus. So R minus H plus. So RH. Here also C6H5 minus and MgBr plus and RO minus H plus. So what you have? C6H5 minus and H plus. That means you are having C6H6 plus MgORBr like this. So C6H5 is phenyl, C6H6 is benzene. So benzene is the product. So what you have to understand here, Grignard reagent with any alcohol, you are getting alkane. But alkane, that depends on the alkyl group what present in Grignard reagent. If the Grignard reagent consists this, like CH2, double bond CH and CH2, MgBr, like this, CH2 minus MgBr plus, with some alcohol, methanol, CH3OH. Okay, sir, here OH bond cleavage, here H plus and this one. That means CH2 propene you are having, CH and CH3 you are having like this. Got it, sir, clearly? So these are about reactions involving OH bond cleavage, and next class we will discuss about reactions involving CO bond cleavage. So till here I hope you understood about acidic nature and about OH bond cleavage, and when the OH bond cleavage takes place easily, when the acidic nature is more, when the pKa value is more, when the Ka value is more, when the pKa value is less. All these things we have to understand and we have to remember. Okay, sir? Thank you.